Okay. Okay, let's get started. So thanks for joining me here today. My name is Lucas Thilosen, and in essence, I'm recording this for some friends and coworkers. I've been in the AI space for a long time now, but large language models are relatively new for me. It's a different type of AI than what I've been working with. So I had to get up to speed quickly. And the last few months, I've learned a lot, and I thought it would be very beneficial to some of my colleagues and friends to record what I've learned as a kind of a 20-minute understanding of what is LLM, what is all the hype about, is it hype or is it reality, what are the implications to my work, to my company, how can I use this to my advantage. In order to do that, I want to drive into, how does it actually work and what is it? So we'll talk a little bit about the technicalities or the technical components of LLMs, and then get into the applications and what this all means for us. Yeah, so this is actually one of my first, it's a diagram that kind of represents one of my first AI applications that I built, which really was just a decision tree, a very complex decision tree of like, okay, if this happens, then this, if that happens, then this, if this happens, then that. And if you don't take much away from today's talk, that's really what large language models are as well. So it's a big decision tree in essence, but I'll go into the details of how it applies to language. So what we'll cover is the technical fundamentals, a lot of the buzzwords that you're hearing and what they mean. We'll talk about, the possible ways you can use this. We'll talk about prompt engineering, what to keep in mind, and then we'll finish off with hype versus reality. What do I see out there? I'm usually not, I'm very cautious when it comes to like hypes. But in this case, I'm actually excited. Like I got excited when cloud came around in 2010. I got really excited about that. I didn't get excited about crypto. I didn't get excited about the non-fungible tokens, but I'm excited about this one. So after this presentation, I hope you share my excitement, but it's grounded in real-world applications. So this is my personal understanding. I'm not the smartest person on this. I'm sure there are a lot of people that actually know, a lot of people that know more about this than I do. And this is not Google's opinion, right? I work for Google, but this is not Google specific. This is about large language models in general. A lot of information is openly available out there. Google actually also put a bunch of free classes out there that you can take and educate yourself. And then the sources I used Wikipedia. I love Wikipedia. Google's research arm, I used their resources, and then OpenAI as well. I used Bard and ChatGPT for some of the experiments that I did. And then, yeah, attention is all you need. We really only need about, if you can stay on for like 15 minutes, I think you'll have a really good understanding of what large language models are all about. So here are some examples of the most common large language models that you will see out there. There's, of course, OpenAI and Google, Meta as well, and then there's some open source varieties. So OpenAI has been coming out with these GPT models. GPT 3.5 and GPT 4 are the ones that are currently powering the user interface, which is a chatbot called ChatGPT. If you don't know ChatGPT, then this talk is definitely too far for you, and you may want to start with that one first. But I assume you do. It will be hard to not know about it. On Google's end, we have Lambda, we have Palm. Palm 2 just came out, and the user interface is Bard, or the chatbot is Bard, so that's how you can interact with these large language models. And then Meta released Llama. So Llama has a variety of different versions out there. 13B is a very popular one. There was a leakage of their fine-tuning. It's open source, it's an open source model, but the tuning and weights were released, and that caused a whole spur in open source applications of the Llama model. They're all staying in the family of that animal. So you have alpaca and whatnot out there. They're really quickly being developed, and it's quite impressive to see what the open source community is doing. Okay, so another way to summarize where we're currently at with large language models is this visualization. So if I had to visualize what the LLM is, the easiest way for me to think about it is like a super excited intern. So this intern right here, right, 2 cups of coffee in his hands, he's ready to go, he's ready to find out whatever you want him to find out and tell you. It's going to find the answers, even if they're not the most accurate answers. It really wants to please you as the employer or boss. So that's a good image to keep in mind as we think about large language models as they stand right now. Now, to get into the technical components, large language models, as they stand right now, are like a fancy autocomplete, like a really fancy autocomplete. In this case, I put in the prompt, "see you later," and the response I got back was "then." So I'm a foreigner who came to the US, and the first time I said "see you later," someone responded with "alligator," which completely confused me, because what does that have to do with "see you later"? Turned out that's a common American saying. And so as I typed in "see you later," I was hoping that the response would be "alligator" as well to validate that, but I didn't get that. I'll talk in a minute about how you could get the alligator response. In this case, the prompt, "see you later," it's called an n-gram. It has 3 words in it, so it's called a 3-gram. And I put these little buzzword signals here, so you know which ones are the buzzwords in case you really want to learn and understand the buzzwords, or you want to take some notes. So an n-gram is an important component. The large language model doesn't actually take the words. What it does, it tokenizes them. So token is another buzzword right here. It means it turns text into these digits. So usually 1 token is about 1 word. It's not always 1 word, as you will see in my examples. I can put in a couple. "See you later." I used OpenAI's tokenizer, which you can find online easily. And U turns into 345. So 345 is what U turns into. When I say "I love you," 345 again is the token for you. However, if U now becomes the subject of the sentence instead of being the object, as it is here, now U becomes a different digit. And then I wanted to try something with a more complex word. Incomprehensible is a much more complex word. However, in this sentence, it's still just this 1 token. The meaning of incomprehensible in the context of this sentence is actually not all that complex. It's just this 1 token. If I provide incomprehensible as just 1 word to the AI, it becomes a very long string of tokens. Now, I talked about the alligator example before. Right, I got "then" as a response, and that's with a confidence interval with a lot of zeros in it. When I look at the Google Ngram viewer, which shows me how likely it is that the next word appears after a series of words, in this case, my 3-gram, "see you later," "then" is the most likely one to come up with this confidence interval. The response I was hoping for, alligator, right, the one from my exchange here in the US, has a much lower probability. It still is there, right, but it's much lower than a bunch of the other words. And these words, the way the probability is calculated, is based on running the large language model over a body of training data. In this case, probably Wikipedia, which is a very large body of text, and a bunch of openly available ebooks out there. So you run it through that and you see what is the most common next word. Now, if I want to, let's take a look under the hood to understand how I could get to the word alligator. I showed you initially kind of the decision tree, right? The if this, then that kind of scenario. And that's in essence what the large language model does as well. It goes through these steps of if this, then that. And it goes through that for a very long string, right? It goes through that for, you could ask it to summarize an essay for you. Or you could come up with an email that you wrote and, hey, can you make this longer or can you make this shorter? And it would go through on what would be the most likely string of words that provide the results that you are asking for. We're seeing here these dots in essence, right? These decision points. Those are the parameters of the model. So you have, right, in my little very simple visualization, you only see a few variables, a few parameters. In the modern version, right, like Palm 2 was just released, you would have 540 billion of these points. And they're not just in a line, they're multidimensional. So they're in all kinds of directions, kind of like it's often compared to a human brain, where in all directions there are connection points. because that's how language is as well, right? It's not a linear thing here. The meaning of something changes in the context of which it is presented. And training that model means, I decide on what the probabilities in the direction are. There are a lot of nuances to training. There's unsupervised and supervised, and we're not going to go into the details of that. You could do an entire talk on training models, but really applying the weights accurately is even more important than the number of variables. And we'll talk about that in a minute as well. One thing that comes up a lot lately, especially, is hallucinations, right? With this kind of large model, there is a chance with 540 billion parameters that the model goes sideways, right? That it goes down a rabbit hole it probably shouldn't have gone down. And you can control that with things like temperature. But for us, like the average user of a large language model, and I think they're gonna put some guardrails in place to limit these hallucinations in the near future. But right now, you could get something that is just factually incorrect, and the LLM will say it with full confidence because it was trained on very intellectually, good data. It was trained on books and Wikipedia, so it can speak like it sounds really smart. But that doesn't mean it's necessarily true, because it just sometimes could go down this rabbit hole, and it ended up with something that is like on the edges, and it's really not. It's related to your prompt, but it's not really related to the facts that you're really asking for. As we think about these larger and larger models, one thing to think about too is the cost, right? I mentioned earlier that 13B for Llama and then the open source versions of that is very popular. Why not 65 billion? Why not 540 billion? Right? That's a great question to ask. And the answer is that, all these parameters cost, right? They are one of the variables that come into the account when you calculate how many flops, how many floating point operations per second would be, or not just per second, but would have to be performed in order to get the results you're looking for. So a smaller model, well trained, might actually provide you with similarly good results, and it costs a lot less. And when you talk about open source development, especially, right, resources and the cost of training becomes very important. There's commercial hardware right now. The NVIDIA A100 is probably the most popular, publicly accessible chip that any kind of company would deploy in their data warehouse with 312 trillion calculations per second. You will hear about GPU versus CPU as well. GPU is more the graphic, was built for graphical purposes. But in this case, these are lots of small calculations that have to happen at the same time. Small is a relative term, right? This is not this is not your little, your old school calculator kind of calculations. These are still big calculations, but they have to happen fast and they have to happen simultaneously so the model can decide which direction to take. And these simultaneously calculating operations are really well suited for a GPU versus a CPU. And that's why you have a shortage right now. A couple things you can do as you think about applications to your company, right? In order to keep the cost down using the pre-trained models, you personally can limit the input and output. I know that like OpenAI, for example, limits the amount of tokens you can put in, so that way the cost stays under control. Right, that's a good way to do it. And then you can fine tune, or you can provide some ground truths to the model, so it doesn't have to go down into all these rabbit holes. It can stay more narrow as it goes through all these calculations variables. Okay, one thing, and this is related to the cost, is how to make the responses better is by being more specific on what you're looking for. And I think the hottest topic right now of all of these is prompt engineering. And that's something you can do right now, like on really getting, making yourself really powerful with these large language models. If you understand, I'm sorry, that's a great website. I thought I had it right here, but it's called Learn to Prompt. So I would highly recommend take a look at it. There are courses on how to be a better prompt engineer. But one way to learn to prompt is by being specific about what you're looking for. So in this case, right, I want to get the response alligator. So what can I do? I can say, instead of just saying see you later, I can actually say complete this fun saying. Fun is a keyword here, right? All the models I tried this with immediately responded with alligator. Now, to be extra nice, I could have said, complete this fun thing with one word. I would provide a max output length of one word. That helps the model a lot because it doesn't know exactly what you want. And the more ambiguity it has, the worse it performs. So if you provide less ambiguity and you say, I want one word, I want 500 words, I want between 200 and 300 words, right? That really helps the model understand what it's working with and what it should work towards. Now, you could also, oh, there we go. That's the website, learnprompting.org. So highly recommend going there, checking it out. A couple of ways you can make it better too, this model and the model's response, is by asking for step-by-step responses. So it explains to you the reasoning on how it got somewhere. And then what you can do as well is provide an example. So providing an example, in this case right now, I didn't provide an example. So it's called a zero-shot prompt. If you provide examples, you may have a one-shot or a few-shot response. Oh, sorry, prompt. So in this case, I'm providing an example here. See you later, Martin. And then Martin, see you later, and then blank space. And all the AIs I used, all the large language models I used, large language models being part of AI, responded with Lucas. That's what I wanted. That's what I was expecting. That's what any human would fill in here that saw this kind of prompt. And that's I would call this a one-shot. I provided one example, and it was able to complete this. If you were to do some translations, like English to German, German to English, right, you could do a few shots to explain how you're thinking about the translation that you want to perform. A couple of things to keep in mind. When you're interacting with the LLM through a chatbot, that chatbot might already have something built in that it adds to the prompt. So as it sends off what you put in to the large language model, it might actually add some wrappers around it. So it might add to it, like, be a friendly chatbot and respond with 200 words, or maybe 5 words minimum, 200 words maximum. It might explain a couple things to the large language model so that your simple response, maybe your question was, what is your favorite basketball team, right? That's a prompt, and the large language model will try to guess what answer you're looking for, which is quite difficult, right? So the more structure it provides, and so maybe the chatbot designers would add some wrappers to it, so the the large language model better understands how to respond to your prompt. Job security. Okay, now what can you do with large language models? Think back of that intern. I think if we all think about, okay, if I had an intern, what would I do? Right? There's a bunch of things how you can make yourself better, how you can make yourself more productive. And that's how I would probably see the LLM right now. I think there's going to be a big gap between people that are embracing large language models right now and think about what can I do to make myself, my output better, and the ones that are hesitant or don't want to use it at all. I think there's going to be a gap at some point. Just think of it as also managing someone, right? Like a lot of my people on my team, they're like, hey, Lucas, I want an intern this summer. And managing someone does take time too, right? It's not just additional 30% capacity or so. You have to explain things, you have to correct things. Interns make mistakes, even if they sound super confident, but you have to fact check things. You can use it as a tutor, right? Like I used it to just go through some of my understandings of large language models, for example. Just be wary of these hallucinations. It's important to fact check what you're getting. And you can brainstorm, right? You can extrapolate out. So it's really great to just bounce some ideas around. You could use it for debate training, right? Like, hey, what would be the counter arguments to this point I'm making? It will always respond. So just be aware of that, right? Even if it should say, I'm not confident in what I'm saying, or I don't really know, but here's something I'm making up. Well, one concern I do have, I have kids, and I think this is really valid. It's always hard to get your first job, right? And with these large language models, in essence, being everybody's intern, how many more entry-level jobs are going to be there? I think large language models are going to supercharge advanced career people, right? Someone who has a lot of experience in the field, you can now really supercharge yourself. But it's going to make it harder, I think, for someone who's just starting out to get started, because like, you have to pay this person versus like you can just get GPT-4, or you can get Bard, you can get one of the like Palm 2 models or so to help you. I do think it's also like a lot of the jobs that are going to be affected by large language models, and where this one is different from other AI examples or even other innovation examples in the past. This will affect a lot of the like lawyers, doctors, accountants, like jobs where you have to understand where comprehension is very important. So it's interesting. I don't think they will get rid of these jobs, but I think it will make them 2x or maybe even 10x of that person, right? The lawyers will be able to cover a lot more text, a lot more documents being supported by a large language model. One question that comes up a lot is bigger better? Right? We have all these, like this massive growth from 2019 to 2020, and then from 2020 to 2023 now, of just number of parameters, and then also tokens trained on, like how many pieces, like how many bodies of text were they trained on. And we just crossed this threshold now where the capabilities are to the point where they are very human-like. Right? The comprehension that we're seeing right now with Palm 2 and GPT-4 is very, very advanced. And so I think that's what is getting people so excited and maybe also scared at the same time this year. So one comparison that people often draw is a comparison to the human brain and the neurons we have in our brain. When I looked into this, it was interesting to see that the elephant actually has way more neurons in the brain than we do. I didn't know that. And then in the cerebral cortex, the human has a lot more neurons. One thing to maybe take comfort in, so the cerebral cortex is responsible for the higher functions. One thing I take comfort in is that only a small percentage of the neurons in my cerebral cortex are responsible for language comprehension and talking. Yet 500 billion parameters are needed just for language. So there's still a lot of if you even want to draw this comparison, but one, I think we can do a lot more with less parameters and just better training. And then I think there's still a lot that is special about the human brain. So then hype versus reality, right? In the beginning, I said this is one cycle, one hype cycle I do think we should pay attention to. But I've been in the AI space for a while. We had a lot of hype cycles. Right? This is probably the fourth or so hype cycle that I'm part of. And usually I've been very cautious. And this time I'm still cautious. I want to see what the concrete implications of this all are. But I do think that, given how fast things are moving, like the performance threshold we have passed now this year and the rate of development that we're currently seeing, it is incredible. This is a trend to really pay attention to. And now, as always with any trend, we see early adopters, and there's going to be people late to the game. The early adopters will, as always, struggle with, let's stay up to date. I mean, even just reading all the papers out there every given day, it's a lot. It's really fast. And so the decision to betting on the right tech is an important one as from early adopter. For the people that are thinking about, let's wait this out and see where it all lands, right? I think it's just important to keep change management in mind. Change management takes time, right? People have to get used to things and things changing. And so as you wait to see what happens, maybe you can start dipping your toes into things and maybe get already some augmentation to your workforce. But I think for myself, I'm certainly looking at how can I 10x myself, right? What is the thing I can do that makes my working hour, not just one working hour, but like I would have worked 10 hours in the past, right? I think back to accountants, lawyers, doctors, and engineers, right? Like the autocomplete of code, the ability to read documents, the ability to understand things, and then condense it for you, the expert, I think is really, really interesting. And then for companies, I think everybody's going to rush to the straightforward use cases. Well, not everybody, but like 30% of all companies in the world will rush to, hey, I want to autocomplete emails, autocomplete documents, autocomplete meeting notes, autocomplete writing code, enhance customer support. Those are very obvious use cases. I think what gets really interesting is when you talk about, okay, what is a competitive advantage I can achieve? Right? If everybody's doing this, what is the thing I can do differently? Right? You can build on top of large language models with your products. And I still think, I've always talked about this, your own data can become very important to reach that competitive edge. And I think that's a really great great conversation to have. I know I will have these conversations a lot on how can you reach the competitive advantage, given that everybody's rushing to kind of the straightforward use cases. So what is it that your company, your product can do that really takes advantage of this disruptive moment? Yeah, tell me what you want to hear more about. This was a really short, condensed talk. I covered a lot of ground. Feel free to rewind it or so, but yeah, let me know what was interesting.